Hello everyone, so for this video we're gonna go over finding the probability of dependent events. Basically, dependent events is whenever you have events that affect each other, so the occurrence of one of them affects what's gonna happen to the following event, right? So it does change. This can change the sample space, so the total amount of possibilities that were at first are not the same, or it's not the same amount anymore. Um, it can even be if we're talking about the same type of event. So let's say like getting, I don't know, let's say there's three blue candies inside of a bag, and then you want to find the event of getting two blue candies, right? So we're talking about a similar type of event because we're talking about the same color of candies, right? Then the first event will be affecting the second one in the sense of the number of blue candies and also the number of total possibilities and total outcomes for the sample space, right? So dependent events, again, they affect each other. Whereas we saw in the other video that independent events are just basically when they don't affect each other at all, right? So the occurrence of the first event, it's not going to change the probability for the second event. So one of the things that we use for dependent events is the conditional probability, and this is the probability that one event occurs after another event has already occurred. And this has to do with dependent events because we are stating that the probability that one event, right, it's being affected by the occurrence of another event, right? I'm gonna go over the formula for conditional probability later. In this video, I want to go over some examples for finding the probability of dependent events. So for this one, we have that three cards are drawn from an ordinary deck and not replaced. Find the probability of the following. So for the first events, I want you to find the probability of getting three jacks. So basically we want to find the probability of getting three jacks. Now, how do we know that these are going to be dependent events? The key word is that we're not replacing. The fact that we're not replacing is going to change the amount of cards that are in the deck as you are taking them out, right? Or as you are drawing them. So that is what's telling us that this is a dependent event, not replaced. If you remember from independent, we said that if it says with replacement or replaced, then it is independent, right? Because you're putting back whatever you took at first. Here, we're not putting back the cards, so the number of cards in the deck is going to change as you're taking them out, right? So that's how we know that this is a dependent event probability or type of situation. So what do we do this? How do we calculate dependent events? Well, the formula says, I'm going to go back to red, that if you have two or more dependent events, then what we do is we're going to go ahead and multiply the probability of the first event times the probability of the second event when the first one already occurred. So again, this is the conditional probability. So we're saying that B is happening when A has already happened, right? So for this, we want to find the probability of getting a jack and a jack and another jack. So we're pretty much finding P of jack and then times the probability of getting a jack when we had already chosen another jack, and then times the probability of getting a jack when we had already gotten the other two jacks, right? And I'm going to put another slash jack. So this looks a little bit like weird because it's kind of long, but again, it's basically we're taking one jack out of the deck, and then that is on the side. So then we want to find the probability of getting another jack, right? When we had already gotten a jack, and then the third card, again, it's being affected by the first two that were taken. So let's go ahead and start with the probability of getting the first jack, right? So we know that there are 52 cards in total in a deck. So let me make a note. So there's 52 cards in total in a deck of cards, and we know that there are 1, 2, 3, 4 jacks in total in the deck of cards, right? So then the probability of choosing the first jack will be 4 out of 52. Now, because we have already taken one jack, right, and one card, and we are not putting it back, then for the second jack that we want to select, we multiply. And then we don't have 4 jacks anymore. Now we have 3 because we had already selected one at first, over 51. So notice how the denominator is changing as well. We took one jack, but then that means that we also took a card out of the deck. So there are not 52 cards anymore. There's only 51. And then for the last one, because we already took the first jack, the second jack, that means that there's only 2 jacks left, and 50 cards in total. Now from here, remember when we are working with fractions and multiplications, we multiply across. So that means that the numbers on the top are going to multiply. So 4 times 3, that's 12, times 2 is 24. And then we multiply the denominators as well. So 52 times 51 times 50, that is going to give us 132,600. Now, these two numbers are divisible by 24. So this is going to be 1 over 5,525. Okay. Okay, so for part B, we want to find the probability of getting an ace, a king, and a queen. So we want to get them in that order, okay? So first of all, I'm going to go ahead and say how many cards in total do we have in the deck. So we have 52 cards in total in the deck. We have 4 kings. We have 4 queens. And we have 4 aces. So again, because there's no replacement, that means that we're working with dependent events. So we're gonna be using that that formula, which is P of A and B. Here it's gonna be NC equals probability of A times probability of A when B when A has already happened, and the probability of C when B and A already happened. Okay, so let's go ahead and find this out. we are going to, let me leave it with red. So the first probability we want to do is find the probability of getting an ace, right? So getting an ace is our event A, getting a king it's event B, and getting a queen it's the event C. So the probability of getting an ace will be 4 out of 52. Alright, so this is a probability of getting an ace times probability of getting a king when we had already selected an ace. So we still have 4 kings. However, we don't have 52 cards in the deck anymore. We have 51. Alright, so this is a king when we had already selected an ace. Times, and then the probability of selecting a queen, we still have 4 queens in the cards, right? However, we don't have 52 or 51 anymore. Now we have 50 because we had already selected an ace and a king. So that means that we had already selected 2 cards prior to selecting the queen. So this is the queen when we had selected the king and the ace. Okay. Now if we multiply, again it's a cross, we get 64 out of 132,600. These two are divisible by 8, and we get 8 over 16,575, and that'll be our probability. So again, it's 8 over 16,575, right, for us to get, an ace, a king, and a queen in that order. Okay, so for part C, we do want to find the probability of getting a club, a spade, and a heart. First of all, let's go ahead and see how many cards we have in total in an ordinary deck. So that is 52. How many clubs do we have? That will be 13. We also have 13 spades and 13 hearts in the deck of cards, right? So the next thing that we want to do is, again, because there's no replacement, we're going to be using the dependent event multiplication rule, right? And that will be finding, again, the probability of a club and a spade and a heart, right? And that means that we're gonna have to find the probability, and I'm gonna do it down here, of a club times the probability of a spade once we had selected a club, and the probability of a heart once we had selected a spade and a club. Okay, so again, the probability for a club is basically the number of clubs over the total number of cards, so that would be 13 over 52 times the probability of finding a spade. It's 13 out of 51. We have 51 because we had already taken one of the cards out, right? And then times the probability of a heart, right? Given that we had already chosen a spade and a club, so we have 13 hearts still on the deck. However, we only have 50 cards in total, right there. So these are the 3 probabilities that we are going to be using and multiplying. So this is gonna give us a total of 2,197 over 132,600, and then this reduces to 169 over 10,200, and that is a probability of selecting a club, a spade, and a heart ordinary